This lecture is the first step in passive solar heating. If we are going to heat our buildings with the sun, we first need to understand the sun angle. Now, we already know that the axis of the Earth is tilted. It's tilted about 23.5 degrees, 23.4 degrees, and that varies over history. That's where it is now. And so, as you can see in this illustration, what that means for us is that in the summer, when our axis is tilted toward the sun, in the northern hemisphere, the sun is going to hit our buildings more straight on. And then in the winter time, as we move around the sun in our orbit, our axis is tilted away from the sun, and so the sun is going to hit our buildings at a flat angle. Here are a couple of illustrations to help us think about that. In the summertime, the sun is closer to straight overhead, and we get a concentrated area of solar radiation. In the wintertime, the sun is low in the sky, and the same amount of solar radiation is spread over a bigger area. If you were to take a sheet of cardboard and cut a window in it, and then tilt that cardboard toward the sun in the summertime, when the sun is close to overhead, you will see that the sun's rays coming through that window in the cardboard strike the earth with a square shape, and there it is. Now, in the wintertime, the sun is low in the sky, and so now if you tilt your window pointed towards the sun, that same amount of opening, the same amount of sun's rays coming through that window will strike the ground at an angle, and you can see that that same amount of radiation is spread out over a bigger area, which means, of course, it won't be as warm, and you need to think about how you design your building. Now, as we think about where the sun is in the sky, we can imagine a big glass dome over our building, and we call that a sky dome. So imagine it was really there. There's your building in the middle, and as the sun goes across the sky at a particular time of year, as the sun's rays come through that dome and hit your building, you could imagine getting like a marker and putting a point on that sky dome where the sun came through. And keep doing that throughout the day, starting in the morning and going to the afternoon, as the sun at a particular time of day pierces that dome. Get a marker and make a mark there. And when you are done, you will find you have a path of dots or marks all the way across that dome where the sun went across the sky. As we know, the sun is highest in the sky in the summertime, and precisely it's highest in the sky at the summer solstice, which is June 20 or 21, depending on what year it is. Here's a picture of the sun high in the sky. Here's another one. Here's a elevation view of a house with the sun high in the sky. Then it's lowest in the sky at the winter solstice, around December 21. So here is the sun low in the sky, December 21. And here's an elevation view of that house with the sun low in the sky. If you look at when does the most energetic solar radiation come through that sky dome onto your house, you will find that the most energy comes in between 9 in the morning and 3 in the afternoon. 80% of the solar radiation comes in during that time. So early in the morning there is sun, but it's not as powerful. late in the afternoon there is sun, but it's not as powerful. So as we're looking at sun angle, we are going to focus on that time from 9 in the morning to 3 in the afternoon. That's the solar window. All right. There are two kinds of measurements you will want to know about when you're planning the windows in your building. And one of them is called azimuth. And azimuth means what angle is the sun on the ground away from true south. So if this is a drawing of a house and this line pointing towards the bottom of the this line pointing towards the bottom of the screen is true south, and the sun, let's say it's the afternoon, mid-afternoon, the sun is coming a little bit from the west. There is an angle from true south to where that sun hits the ground, and that is called the azimuth. In addition, you want to know how high is the sun in the sky. From a line on the ground, what is the angle up to where those sunbeams are coming in? How high is that? And that is called the altitude. So you are going to measure two things: the azimuth on the ground, how far is it from true south, and the altitude, how high is it up in the sky. And you project those lines, the azimuth and the altitude, onto your imaginary sky dome. By the way, Norbert Lechner, whose pictures I'm reproducing here, specializes in passive solar heating and passive cooling. He is a professor of architecture at Auburn University, and so I'm using his illustrations because they really are the best. So here's his sky dome. You know how if you look down at a view of the Earth, let's say you're looking at a globe and the globe has these lines of latitude circling it. If you look straight down at the Earth, it flattens. It looks like just a bunch of flat circles. Those lines of latitude look like circles when you're up on top looking straight down. And those lines of, they're like longitude, those azimuth lines on your sky dome, you can project them straight onto your flat view as you're looking straight down at your dome. So this flat disk up above is what your sky dome would look like up above if you projected it onto let's say, a flat sheet of paper. And it's that flat projection that we're going to look at when we look at sun path diagrams. So now, there are a lot of lines and numbers here, and it really helps to slow way down. I know we want to just charge through this and get our answer, but that is kind of hard to do when you have so much data to sift through. So let us just slow down and try and think about what we are looking at. For the moment, ignore this band through the middle of the circle and just look at that flat disk that we were talking about. Let me back up. Here's our flat disk that we were talking about with our circles that show the altitude on the dome and our straight lines, our radial lines that mark the azimuth angle. Okay, so this graph that we have here has circles that represent the altitude on your sky dome. See these circles on the dome? Those are shown in the top view in our graph. And then the azimuth lines, which are kind of the longitude on our sky dome, the azimuth lines are these straight lines, these radial lines going straight out from the center. So here is an example of an azimuth line. Here's our house over here where we've marked what angle is the sun away from true south if you look at it straight down on the ground. Here is that line projected onto our circular flat thing. Here is that line sitting under our sky dome. And here on the right is that line traced onto our sun angle diagram. So there's an azimuth angle right there. Then the altitude, over here on the left, we see the altitude angle, how high is the sun in the sky. And that angle, as it pierces our sky dome, it traces a circle somewhere on our dome. And if we go up and look at our flat disk up above, we see that particular circle traced onto our flat piece of paper. And now if we look at our sun path diagram over here on the right, there's that circle traced onto our sun path diagram. So that circle represents an altitude. Now, over the top of these azimuths and altitudes, and let me back up just for 1 second. I want to point out that the altitude circles are marked with degrees. So there's a very flat one at 10 degrees. Here's a rather steep one at 50 degrees, and so on. And then the azimuths are marked at the number of degrees away from true south. So that's what those numbers are. Numbers on the circles and numbers around the outside are marking altitude and azimuth. All right, so a sun path diagram. Now we take a band of lines which show the path that the sun took over our sky dome, and we superimpose those lines over our chart here. And notice how this particular chart says 36 degrees north latitude. That's further south from where we are. This is what their sun paths look like. If we look at a sun path diagram for Eugene, Oregon, these lines will be bent just a little bit differently. It will look quite similar, but not identical. So each latitude on the planet will have a different, slightly different sun path diagram. So here, this one is for, I don't know, somewhere down in California. All right. Now, each one of these lines going side to side represents the sun path for a month. And it happens to be the 21st day of each month. And you can just barely make out here. Over here on the side are Roman numerals. So numeral 1 is January. Numeral 2 is the second month, that's February. Roman numeral 3 is the third month, that's March, and so forth. I will point out that Lechner and also Charlie Brown at the U of O like to use Roman numerals. Some sun path diagrams use numbers over there. All right, so that's what those back and forth lines are. Those are particular months. Then you see some sort of up and down lines. They're curved, but they're up and down. And across the top of what happens to be the line for June, you see these numbers. Those are hours of the day. So right here, there's a line that is marked 9. That's 9 o'clock in the morning. And over here, to the left of center, there's a line that's marked 3. That's 3 o'clock in the afternoon, and so forth. So we've got lines for the months, and then we've got other lines for hours in the day. Now what do we do with these? Let's say you're trying to figure out where to put the windows and the overhangs in your house. First, let's look at the azimuth.